Good afternoon, ladies and gentlemen. Let me introduce myself. My name is Amalia Narifa, and for this opportunity, I will present to you about our research. So, this is my research. Let me show to you my slide. So, the title of this research is Analysis of Wet and Dry Season by using the Palmer Drought Severity Index, or PDSI, over Java Island. The main author of this research is Mrs. Sinta Berliana Sipayung. The other author is Indah Susanti, Bambang Siswanto, me, Amalia Latifah, Hidayatul Latifah, Dewi Tono, Lilik Slamet, and Mamat Suhermat. We are from National Institute of Aeronautics and Space in Center of Atmospheric Science and Technology, or in Indonesia is PST8, Pusat Sains dan Teknologi Atmosfer, Lembaga Penerbangan dan Antariksa Nasional. So why this research is important? Why we did this research? This is the background of the research or the introduction phase. So the drought is an extreme climate event that characterized by low rainfall accumulation for several months, several years, or even several decades. Drought itself is a natural disaster that is very difficult to identify and analyze. Why? Because it is a multi-scale phenomenon and it's a very complex parameter to identify and analyze the drought. Identification of the characteristic of drought is very important for the planning and management of water resources. So the calculating of drought, one of the method is PDSI, or Palmer Drought Severity Index. It is developed by Palmer by combining rainfall and potential evapotranspiration into a hydrological system that includes a two-layer type model for calculating soil surface moisture. The PDSI, or Palmer Drought Severity Index, is a meteorological dryness index that is commonly used and widely accepted. PDSI variation has been used to measure long-term change in land surface dryness. And PDSI has a wide value. It's between -10 until +10. The negative is, it means when the value is negative, it means the dry event. And when the value is positive, it means the wet event. So in this research, we analyze the relationship between El Nino short-term oscillation, or ENSO, and Palmer Drought Severity Index to determine the occurrences of the wet season and dry season based on climate database in Java. So this is the method of this research is PDFI. The calculating of drought event is with PDSI. The input data of PDSI calculation is rainfall data that is from climate data. This data is collected of monthly climate graded datasets, and this data is available from 200 until 2019. This climate data is an assimilation from CRU, or Climate Research Unit data, and GRI 55. And the climate data has been validated using station data from the Global Historical Climatology Network to become 4 kilometers high resolution spatial data. PDSI estimated the duration and intensity of drought events by measuring the moisture supply based on the water balance equation. To get the soil moisture anomaly index, the Palmer method is used. We start from the calculation of temperature, potential evapotranspiration, and water availability. So this is the table of PDSI classification. If the value is 4 or more, it means extremely wet, and if the value is negative, it means the dry even occur. So if the value is below -3, is a very extreme drought. This is the result of and discussion section. In general, the characteristic of average monthly rainfall on the Java Island temporarily have fluctuation, and it has the monsoon patterns. What it means? in Java, there is a high rainfall accumulation in December, January, and February season, and it has a low rainfall accumulation in GGA season, or June, July, and August. It follow the monsoon patterns. So we found a good agreement between Climate Data Time Series with special rainfall for Java Island, especially when long wet season coming over Java Island in 2010 and 2016. And also when long dry season occur in 26 and 2015. It also there is a good agreement between Climate Data and special rainfall data in Java Island. So this is the frequency distribution of PDSI in Java in 2010 and 2016. So this is the monthly average frequency of PDSI in when La Nina event. As we can see that there is a positive result as it has more positive result than negative result. So when La Nina event occur in 2010 and 2016, there is a positive PDSI calculation occurred. So we found in this 2010 and 2016 event, or when La Nina event occur, the PDSI value is positive, with high frequency reaches 215. 250, I mean. So it has a very high frequency. So we found that the distribution frequency technique more clear when the technique is applied in long wet season in 2016, with PDSI value has a negative and positive value, but there is a lot more positive value than the negative value. So this is the frequency distribution of mean PDSI in La Nina event. So as we can see that there is more negative value in 2015, but there is a positive value also in 26. So what it means? The monthly average frequency distribution when El Nino in 26 and 2015, we know that there in 2015 there is a strong El Nino event occur. So it means then when strong El Nino event occur, there is a negative PDSI value. So this is the conclusion of this research. Number one is climate data monthly temporal and spatial resolution of around 4 kilometers found that when in dry season occur in over Java Island. By using PDSI, the long rainy season came on the island of Java in extreme wet, and also in dry season in El Nino event. We found that in La Nina event or extreme wet event, PDSI value reached positive 8 in 2010 and reached almost positive 6 in 2016. When El Nino occurred in 2015, PDSI value reached negative 5, and in 2015, the PDSI value reached negative 3. So that is my research. Thank you so much for your attention. Good afternoon.